Good afternoon to Gillian Butler, and thank you for joining me on our podcast. And we had a little bit of a chat last week about what we're going to talk about today. And I'm really looking forward to this conversation. And as we've just discussed, I'm going to let you introduce yourself because you'll do a much better job of it than I will. So, hello.
Hello, Glenn. Thank you for inviting me along to this. My current role is a researcher at Newcastle University, but I've been working for quite a while and worked through a number of different roles, mostly working with farmers in various roles that I've played. But as I say, everything has come together in the research that I've done at Newcastle University in recent years. Mostly looking at how the management of our livestock, whether it's cattle, sheep, pigs or poultry, affects the nutritional quality of the food that they create for us, with some interesting results.
Amazing. Right, now I'm going to unpick that and ask you to backtrack and tell me about your, because obviously this is, if you're researching this, is something that you be very passionate about. What was the kind of path that has led you to this? What did you study? What did you want to do when you were much younger, and has it led you to being where you are today?
Well, I was an agric student at Edinburgh University, and I've got to admit at this point, my father was adamant that there would be no jobs for women in agriculture and tried to dissuade me from doing agriculture. But I did agriculture, and right. In the 1970s, I started working for the Government Advisory Service as a nutritionist, an animal nutritionist.
And animal nutritionist, as in sorting out diets for animals?
Diets for cattle and sheep, mostly. Dairy cows, beef, cattle and sheep. And the priority at that time was to improve efficiency of production on the farm. So most of my early life was spent trying to get farmers to feed more forage to their animals for economic reasons.
And by forage, you mean grass and pasture?
Grazing, silage,
right.
rather than grains. Cereals. Rather than grain, because of the cost difference. And if we could throw legumes into that and have clover to supply the nitrogen, so much the better. But it was all driven by economics to help the farmers make more money and be more efficient. And it was only maybe 20, 30 years later, when I started looking at the nutritional quality of the food we're producing, I realized that these high forage diets, especially grazing diets, had a huge positive in terms of the health of the consumers, as well as economics for the farmers. So,
I just find that super interesting, because obviously now very, very little grazing animals are completely grass or forage finished. So you're saying that you were coming at this a few decades ago with the intention of saving money, and yet what I'm reading is that it's grass-fed meat, or 100% grass-fed meat, is fetching a premium over grain finished. So how has that shift happened? How has that kind of come around? It seems to be more expensive now to finish on pure pasture.
It's more expensive because they don't grow as fast, and that's I suppose years ago the justification for feeding more cereals was to intensify the ration, was because the animals would grow faster. We were importing the genetics from the continent, these large Charolais, Limousin, Belgian blue breeds that would essentially, they needed grain to finish, and they wouldn't cope with the forage-based system. Their genetics are such they need a very high plane of nutrition. Whereas our native breeds are better suited to the forage system that maybe our ancestors have managed on their farms.
I don't think I quite realised that. So, because I know there were these, I had heard about these breeds like Limousin that came over. That. So when was that? Was that 70s, 80s that all that was happening, or?
Yes, I remember in the late 70s and early 80s, a lot of these continentals, as we call them, were coming into farms, and the Herefords and the Anguses were losing favour.
So yeah, because I've as I'm sure you know, I have worked a lot on PFLA farms. I've visited a lot. I've made films with a lot of PFLA farmers, and I was interested that they tend to choose native breeds to completely grass finish, and often they're choosing native breeds that are not just native to Britain, but native to Lincoln or Devon or whatever. So, farmers I visited in Devon have Devon Reds, and in Lincoln they had Lincoln Reds. And do you think, is there a real case then for actually really matching these native breeds to even the part of the country where they're from?
I suppose I have to admit, I don't know of any scientific evidence for local breeds,
Right.
other than they have evolved to cope with the local conditions. But certainly UK native breeds tend to be smaller, and they are what we call earlier maturing, so they don't take as long to reach slaughter weight, and they can do it on lower input systems. Whereas,
Yeah, I guess that's historically the genetics would have, the ones that would have done well on pasture and survived through whatever difficult winters or whatever would have been the ones whose offspring became stronger, and it would have had that kind of positive feedback loop.
yeah, it's a classic thing that I talk about in my sheep lectures, that the hill sheep, it's only those that can breed and survive in a hill environment that pass their genes on to the next generation.
Right, that's logic, right?
Those that can't cope die out.
Classic natural selection
Yeah.
process. Right,
Yeah.
right. Okay, so you're backtrack a bit. You're doing this research into trying to get farmers to do more pasture finishing as a cost saving exercise. Was that the point at which you then started to look? You were coming at this from an animal nutrition point of view, but when did you start looking at the human nutrition aspects of it? When did that come into things?
That probably started when I joined the university, just about the millennium. We got some funding. Most of the research was actually funded by European money they're called framework projects, which were the successors, if that's the wrong way around, the following on, earlier versions of the Horizon program that's just recently been introduced this week for European funding. So we had this European money to look at health and safety of low input and organic foods. Our first project, we called it C.L.E.A.R, quality low input food, and we were looking at health and safety of food under organic and other low input systems.
Right.
And our first work was with milk quality, and it was actually driven or almost designed by the farmers themselves. With so many things, especially that we see now with sort of regenerative practices, it's industry led, and the science has to catch up. So the farmers thought their milk was better
Right.
than mainstream milk. So we built a project around this, and we looked at low input organic farms and pasture only non-organic farms, and we did find differences in milk composition in the fat profile in the milk. That was starting around 2005, 2006. We started finding these results.
So this is just sort of a basic comparison between conventional and organic farming, looking at the products and what nutrients that benefit human health are in these different products, and looking at the differentiation.
Yeah, most of my research is looking at the fat composition, the
Right.
fatty acids that are in the fat. We also looked at antioxidants, things like beta carotene that gives cream its nice yellow color in Jersey milk. We looked at that in the early days. And the bottom line was, the more forage were in the diet of these cows, the better the milk was for our health. We couldn't say it was, well, the composition was better for our health, suggested it would be better. Unfortunately, even to date, we haven't been able to run a food study where where consumers have tried different diets and compared their health. Long-term project that Nobody's going to fund that,
No, but
unfortunately.
it would also be pretty much impossible because you'd need to do like a randomized controlled trial, double blind placebo. You'd need to take identical twins and have the only difference being one having organic and one conventional, and then
That,
look at them 10 years later and see
yeah,
if that, yeah, it's
nobody's going to fund that,
no, no, the
unfortunately.
classic, what's it called, epidemiological study problem that you get. So, okay, but the thing is, though, you can kind of put two and two together, right? We know that there are certain compounds that are beneficial to human health. We know quite a lot about the role of different fatty acids in human health. But tell us how that differs. Tell me about fats in the human diet and why they're important and how they differ.
Right. Well, I think that's certainly important before I go on to talk about the findings
Right.
that we got.
Give us,
Otherwise,
yeah.
so what? So, as I say, we were looking at fat composition, and fat in milk and meat and eggs is mostly made up of fatty acids, which are long carbon chains. Well, anything between 2 carbon chains for the simplest one up to 24 carbons, mostly even numbers. And if there's no double bonds between the carbons, then they are known as saturated fatty acids. If there's one double bond somewhere along the chain, that's a monounsaturated fatty acid, and the most common monounsaturated fatty acid is oleic acid that we get from olive oil or UK production in rape oil. And that has a double bond between the 9th and the 10th carbon atom, about halfway along this 18 carbon chain. And if there's more than one double bond along the chain, that's a polyunsaturated fatty acid.
Right.
And there's 2 polyunsaturated fatty acids that are classed as essential. One is alpha-linolenic, which has 3 double bonds, and the other one is linoleic acid. It's like
So that's
confusing with the
ALA is an essential fatty acid and linoleic acid. And am I right in saying linoleic acid is an omega-6 fatty acid?
Yep, I was going to come on and talk
All right.
about alpha-linolenic is known as an omega-3 fatty acid, and that is because the last double bond is 3 carbons in from the end of the chain, in my simple terms, and linoleic acid is an omega-6 fatty acid because the last double bond is 6 carbons in from the end of the chain. You might think it doesn't matter particularly where the double bonds are, but all the different fatty acids have different roles within the body and different places in the metabolism. These are both essential. Mammals can't synthesize these fatty acids. We have to rely on getting them from our diet. There are other omega-3 fatty acids, long chain omega-3 that we talk linked to fish oil, EPA, DPA, and DHA, that are 20 and 22 carbons long with 4, 5, and 6 double bonds. But in theory, we can synthesize these, but the elongation of the carbon chains going from alpha-linolenic to DHA relies on the same network of enzymes that our omega-6 pathway does. I don't know if there's any opportunity to show a slide or not. Is there?
I can, yeah, if you send me something, I can drop it in on the video.
All right.
Please do,
Okay,
yeah.
I'll send you the
Thank
metabolic
you.
pathway, not to get bogged down in the
Yeah.
detail, but in order to make the long chain fatty acids, we need to have ideally less omega-6 in our diet, so less of the linoleic acid in our diet.
Because it uses the same pathway. Do you know
These,
what? Now I get the ratio of 3 to 6. I didn't understand what the reason
right.
was for reducing the 6. You've explained it brilliantly. Thank you.
Because they think through evolution we had as much omega-3 in our diet as omega-6, 1 to 1. And these enzymes worked, and our bodies and the animals, our cows as well, were able to convert and make these long chain fatty acids. Now Western diets are typically between 7 and 20 of linoleic acid to alpha linolenic to the omega-3. So the enzymes are swamped with the omega-6. It's particularly marked in American systems or other countries where they rely a lot on maize or maize oil that's high in
And
omega-3.
soybean oil and
Yeah,
yeah,
they're all high in omega-6.
yeah.
This mismatch in our diet has come about because of the introduction of vegetable oil and things for cooking, margarine instead of butter.
Yeah.
It's all going to
So,
balance those.
so these oils that contain omega-6, as long as they're not oxidized and as long as they're, they're from a good quality source, they're not kind of inherently harmful to us. It's all about ratios.
They're not harmful, and they are essential, but if we've got too much of them, they stop the metabolism to make the long chain omega-3 and these long chain omega-3, the DHA, DPA, they're essential in nerve tissue. They're a shortage of omega-3 is linked to a number of health conditions, both linked to mental health as well as physical health, cardiovascular health, cognition, even things like dementia, and that are being linked to a shortage of long chain omega-3.
And that shortage can simply come not just from lack of consumption, but from overconsumption of
Yeah,
omega-6, right?
yeah, yeah.
Amazing.
And so I think the bottom line for health is to have foods that have more of these long chain omega-3s in, so things like fish or lean meat. Beef has been shown to have reasonable levels, but also less of the omega-6.
Right.
So the balance is important, but also the level per se of omega-3.
Now, okay, so I think he's kind of started this by telling us that there is a difference between a pasture-raised animal and a grain-finished animal. So how does that work?
Yeah, and just before I talk about the results, I'll explain how they came about, maybe, because
Yeah, please. Yeah, yeah.
essentially cereals and seeds are high in omega-6, and leafy material, vegetation, is high in omega-3. So animals that are fed cereals, and we see this particularly with eggs, where poultry are fed 100% cereal diets, they have really high levels of omega-6 fatty acids and not a lot of omega-3 fatty acids. The ratio is sort of 15-1.
So that's for all eggs or
It does vary, and we have got a study. I'm writing a paper just now looking at supermarket eggs produced from different systems, and there is a difference in the ratio.
right.
If they can go out and consume some pasture or even maybe some of the bugs that eat the pasture, then we see higher levels of omega-3 in organic poultry, not necessarily free range, because I'm not convinced a lot of free range birds actually go outside, but
That's something I want to pick up on in a bit. Yeah. No, it's funny when I started working with C.L.E.A.R, and I often people often ask me what's my biggest bugbear in food labeling, and I always say that free range is the most abused term, I think, of all. But so really, we need to look for organic, pasture-raised eggs to get the healthiest we can.
Yeah, I mean that work isn't out there yet, but it will be, hopefully.
Okay.
Within the next few
Please
months.
let us know when that is.
So I'm always wary about talking too much about things that are in the pipeline,
Sure.
because
Okay, I won't hold you to that. Thank you.
the publishers could turn around and say, well, that's not new. We know that because you've talked about it too much. Anyway, that's so to go back to the meat, we did a study under another European project where we were looking at supermarket meat that was non-organic, organic, and we had some from Pasture for Life, and we also had some steak that came from conservation grazing farms where the animals were kept purely to maintain the vegetation balance that they wanted. So they would probably be on quite diverse pasture. And we saw a step in the omega-3 to 6 ratio where it was much higher in the non-organic supermarket meat, next coming down to the supermarket organic, and then the Pasture for Life, and then the conservation beef. The conservation beef and the Pasture for Life beef didn't vary significantly. They were in terms of the ratio, I think it was about 1.5 or 1.9 to 1. So between 1.5 and 2 of omega-6 for every 1 of omega-3.
Oh, wow. So if your fat content in your diet was only coming from that beef, that's about as perfect as it could be.
Yeah,
that's all you need.
Yeah. But even if there are other fats in the diet, it's the total diet balance that is important.
Sure.
We want to get less than 4 to 1. So anything that's lower than that is going to pull down the average for the total diet.
Got you. Okay.
It's like,
you say less than 4 to 1, but what do you think is optimum for humans? Is it literally 1 to 1 is as good as it gets, or?
The guidelines at the moment is between 2 and 4 to 1.
Okay.
As being realistic. So as you see, our Pasture for Life beef is at the low end of that ratio, so it will help the overall balance. And we've done a similar thing with milk, and 100% forage diets on milk are we got less than 1 to, it was something like 0.9 of omega-6 to 1. So we've got more omega-3 fats in pasture-fed milk than we have omega-6 fats.
That's amazing. So if you're consuming pasture-fed milk, pasture-fed beef, you can afford the odd dollop of mayonnaise, the odd bit of salad dressing, the odd maybe bag of crisps or something.
Essentially, yeah. So pasture-fed butter would be much better than margarine in terms of the balance of omega-3 to omega-6.
That's amazing. So I didn't quite realize there was that much of a difference in the and the grain finished. What sort of ratios are you looking at in the kind of the worst case scenario?
Well, the supermarket non-organic was 7 to 1.
Wow.
And they would have had some forage in their diet, a UK-based system. These were bought in May, June, so possibly not out grazing, but they would have had silage or something. I mean, we don't know the details.
But they would have been grain finished towards the end of their life, which is where they put the fat on, and that fat would have come from the grains they were fed.
From the cereals,
Right.
But I think it would be possibly less intensive than a feedlot, I say a US feedlot type system.
Yeah, I mean, to the best of my knowledge, so I spoke to a guy called Stefan van Vliet at Utah University, who's very knowledgeable about the nutrient content of beef, and he said the worst beef he'd ever analysed in terms of nutrient quantity was feedlot beef, where 75% of the diet of the animal had come from bioethanol production from corn. So after you've brewed the bioethanol, the waste products are then fed to cattle. And they really spent very little of their growth had come from, like they maybe had a month or two on pasture, and then they were just fed this waste corn bioethanol rubbish. And he said that was very, you're basically drinking vegetable oil when you're eating that beef. It's awful stuff. And the best he'd come across was Swiss kind of organic, nomadic, pastoral mountains. So, which has brought me to something I'd like to ask you. Is there a difference then between grass-fed and pasture-fed?
We haven't looked at that with beef, other than our Pasture for Life, where the 2 farms we monitored, they had quite diverse pasture.
Right.
The Pasture for Life versus the conservation, we had some differences there. But we haven't looked at it in beef. We have looked at it in more in milk, and there's quite a bit of details in milk, sort of a fertilized grass pasture versus a grass clover versus a multi-species
Species.
sward.
Right.
And
Interesting.
we do get differences there. I don't want to pull in another complication, but in the early days of our milk, the farms that used nitrogen fertilizer had more conjugated linoleic acid in their milk,
Right.
but less omega-3 compared to the organic farms that only grazed that had more omega-3 and less CLA. But
And I know C.L.E.A. I've seen it. I know that I've seen it sold as a sports supplement. So can you tell me a little bit about that?
CLA metabolism is very complicated. There isn't a single molecule which is conjugated linoleic acid.
Okay.
They are deviations from the omega-6 fatty acid that I'm talked about, linoleic acid, which has a double bond between, if I get it right, 3 and 6 and finishing on 9. So it's 8 to 9. Conjugated linoleic acid has the double bonds on adjacent carbon atoms. The most common is between 9 and 10 and 11 and 12, CLA 911. And that one has been shown to have anti-cancer properties. Other CLA molecules, and there's probably about maybe 20 different molecules that are, they're all, they come from fatty acid metabolism in the rumen, by the rumen bugs.
Okay.
It's a bit complicated, and I was hoping to avoid the discussion.
Oh, sorry.
Most of the CLA in milk and pasture-fed milk is quite high in conjugated linoleic acid, comes from a monounsaturated fatty acid, racemic acid, that's produced in the rumen from alpha-linolenic metabolism by the bugs, and then that is a monounsaturated fatty acids, and it gets a double bond added in the udder to turn it into 9 and 11. Racemic acid is a T9, it's a trans fatty acid, which is another complication.
But not a trans fat in the same way as like a
No, industrial trans fat is very different from natural trans
natural trans
fats,
fat.
and that's another topic that
That's
you might
another
want to talk about.
wormhole that we probably shouldn't go down.
Yeah. So that's one difference we've certainly picked up with milk, with diverse pastures versus fertilized grass pasture.
So just to sort of as a summary there, CLA isn't one molecule. It's a group of different
It's a group
of different things. They generally have a beneficial effect on humans, and I've read about them helping people for weight loss, and I know that a lot of people who are like lifting weights and bodybuilders use it as a way of getting cut and losing body fat. I had also read about it for anti-cancer properties.
Yeah.
And as I said, I've seen it for sale as a sports supplement. And I also know that the Pasture for Life, it's one of the things stated on their website is that high levels of CLA are in pasture-fed beef. And so far, I feel like we've been talking about cows, but is exactly everything that we've talked about so far also true for sheep?
I would have thought so, but there isn't the evidence. If you see that the work hasn't been done. Bristol University did look at sheep meat quality back probably about 15, 20 years ago, and they did differentiate between salt-fed salt marsh lamb versus heather-fed lamb versus feedlot lamb. I can't remember the details, but it's similar to our work, and that work hasn't been taken up and moved on from there. As far as I know, most of the work today has been with beef.
And is
But
that simply
I
just
don't
because we
see.
eat more beef than lamb, or that do you think there's less difference in different finishing of lamb, or?
I think the difference in lamb is probably less marked than in beef, because generally speaking, finishing lambs tend to have more forage in their diet anyway.
Got
So
you.
if you like, mainstream lamb is probably going to be, it will have quite a bit of forage in their diet.
Understood.
You
Yeah.
don't
So
have
there's
the feedlot
less of a
systems.
big difference between the good and the bad with lamb.
Yeah,
Got you.
I
Okay.
think so, but
Right.
that needs to be proven.
And can you have you done much research into the monogastrics and the effect of diet? So you talked about eggs a little while ago, but what about pork and chicken? Because I wrote something a little while ago when I was working for a company called the Ethical Butcher about how pasture-raised pork that hasn't had too many grains the fat was very, very high in oleic acid, and very heart protective. And actually, when our sort of, let's say, our great grandparents had a choice of cooking fats, they had lard, tallow, butter, and ghee, and that was about it. Before the vegetable oils sort of came along, and that the pork fat was actually one of the healthiest fats that we could consume. Do you know much about that? Can you talk to me about that?
Not authoritatively, but
Okay.
if the pigs have been eating feed that has unsaturated fats or like oleic acid, and I suppose historically pigs would have been fed from our table scraps
Yeah.
and kitchen waste, so they would be getting similar balance of fats to our ancestors. So probably less purified grain and maybe, some butter or recycled pig fat, possibly.
Yeah, the
Or
pigs would have been the food bin of the past, right? And kitchen scraps and swill. So unused food from institutions was fed to pigs before,
yeah,
a while ago. So I guess if there's not the omega-6 in the system that's feeding them, they're going to produce a higher omega-3 ratio anyway. But they
yeah,
don't have like a sort of upcycling or filtering. It's very similar, is it, that if they're fed a grain-intensive ration, the omega balance is going to be out with pigs as well?
um, yeah, it will be. I'm just hesitating because we had a paper out where we were feeding insect meal to poultry and looking at the fatty acid in the eggs. Our defatted black soldier fly larvae were incredibly high in saturated fat, in particularly, I can't remember the name of it, C14 myristic, I think it is. And yet the poultry were able to filter that out and minimize the amount of that was going into the eggs, presumably to protect their embryos.
Interesting. So that would be like a long chain fatty acid.
Well, it's a 14, it's an intermediate fatty acid.
Right.
And our conclusion in that paper was it would be better to eat eggs from poultry that had been fed the soldier fly than it is for us to consume the soldier fly ourselves, because C14 is not a healthy fat. That is one that's a saturated fat that is challenges our health.
Interesting.
Linked to
where would we find that fat in our foods then? Where would we find C14?
most food will have some in it, small quantities.
Right.
We were surprised at the amount we found in the black soldier fly larvae. And I don't know, I mean, most animals, the fat in their body will reflect what they're fed. These larvae had been raised on waste pasta. It was an organic system. They'd been fed on pasta waste.
It wasn't a company called Better Origin, was it?
I'm not sure. It was in Switzerland. These were
Okay.
partners in one of our European projects, and they sourced it. We said, well, okay, we'll look at the fatty acids in the diet, because they were looking at the logistics of production from black soldier fly to try and reduce soya.
Yeah, because I did come across these guys called Better Origin who were doing that for British poultry farmers, whereby you put a unit on your land, like a shipping container, that grows these bugs, and you feed them from supermarket leftovers, mostly waste vegetables, and it grows the black fly larvae. You feed those to the chicken, and you've essentially double upcycled supermarket leaves into protein, bioavailable protein for humans, which is either broilers or egg layers. And it seemed like a very sensible system to, again, as you said, just cut the reliance on the soy.
Yeah, and if the diet of the black soldier fly, the larva develop, is high in omega-3, then their bodies will, and therefore that will get into the eggs or the poultry meat.
So everything is circular. Incredible. Yeah. So
And with our pigs and poultry, it's almost a straight reflection of what's in their diet ends up in their bodies. Whether it goes into the eggs or not is another question. Whereas with the ruminants, the bugs in the rumen, they really muck up fat metabolism within the ruminant system, and we actually lose about 95% of the polyunsaturated fatty acids that the cow eats before it goes into the milk or the muscle. That's why animal ruminant products are high in saturated fat, because the cow's diet isn't high in saturated fats. The cattle don't eat saturated fats, but the bugs in the rumen strip out all the double bonds and turn everything into saturated fat.
So this is something that when I discovered it, I found it was like quite mind-blowing. And correct me if I've understood this correctly, that in a sense, a cow doesn't really eat grass. A cow kind of eats the byproducts of fermentation of grass in its stomach. Is that kind of correct? So
I could be pedantic and say the cow does eat grass, but it doesn't digest the grass.
Okay, right. So these bugs are digesting the grass, and one of the byproducts of their metabolism are the short chain fatty acids that the cow can then absorb and turn into other fats. Is that not?
Yeah, well, to burn them for energy, a cow system,
Right.
a ruminant system doesn't have a lot of glucose going around in it because it doesn't digest carbohydrates.
So cows are in ketosis, are they?
They can, especially we see it in sheep in late pregnancy and cows in early lactation, where there's a demand for glucose by the fetus or going into make lactose in the udder, and it's not uncommon to be ketotic at that point.
Interesting. So that brings into the interesting question then. If that's kind of, if cows are naturally running in this sort of keto state, and then you go and throw a load of grain into their rumen, which is made up of complex sugars, surely that's really going to send things going.
The cows don't digest the grain into sugar. The grain is metabolized by the bugs in the rumen to produce the volatile fatty acids, acetate, propionate, and butyrate, but also lactic acid. And that's where we get acidosis when they have too much grain. If the balance of the bugs isn't used to grain in the diet, that's why we can't change their diet suddenly. So the bugs in the rumen produce lactic acid, and that's quite a strong acid, and it can strip out the lining of the gut and cause all sorts of problems and kill the animals. So grain still ends up going through the fatty acids, the volatile fatty acids or lactic acid.
So it's not shifting the cow's metabolism into a glucose burning state. It's more to do with the gut biome not being balanced, or
propionic acid that's produced from grain, a volatile fatty acid from grain, that is glucogenic. But acetate and butyrate are not, and we tend to get more acetate and butyrate from forage-based diets.
And they're the classic kind of ketones, right? That the animals are.
That is their mainstay for energy metabolism.
Right.
That will go. I remember doing the biochemistry 40 years ago at university.
So okay, I think where we've come to is
We've gone,
we've gone off track a bit. But if
yeah,
cows are fed too much grains too quickly, it causes them health problems.
yeah, it can kill them.
Right, right, right. Because it would never
Yes.
occur like that in nature. Because in nature,
No.
cows must eat some grains, right? They would chew on the head of a flowering seed or something, and
Yeah, although the starch levels in, say, grass seed heads is so much lower than in our they're not highly evolved cereals, highly selected cereals,
right,
where the grain are quite plump and 50-60% starch in a milled wheat, as
that's not
opposed to,
natural. Yeah, yeah, yeah.
no.
So
So
yeah, so there's a difference. So what I think where we've kind of come to with a bit of technicalities is that there is quite a huge difference in the human health aspect of different finishing systems.
yeah,
There are a lot of different finishing systems available and that are used. I think I read that there are 11 different or 50 globally or 11 in the UK of different ways of finishing beef, for example, of different combinations of how it's done.
yeah. I mean, I wouldn't. I would hesitate to say there's a finite number because there's so many variations, and
Right.
some will, and throughout their lifetime. I mean, bearing in mind it might be maybe 2.5, 3 years before the animals are finished, so they could change several times. And certainly throughout the seasons, they will change. The diet will change naturally, and in a natural system, their diet will change throughout the seasons. But yes, we have a huge diversity in feeding systems for our farm animals. One extreme would be a feedlot, and then the other extreme would be, I suppose, like the conservation grazing animals that I talked about that are kept very long term, primarily to manage the vegetation.
I was going to say more for an ecosystem service than actually for what they're providing for us. Yeah. So bearing that in mind, it would be, if we're sort of pulling this back a little bit to C.L.E.A.R and what we're talking about in relation to C.L.E.A.R campaign, it would almost be more difficult to, or it would make more sense to include nutrition data on the food product than it would method of production data, because the method of production is going to be quite complicated unless it's, say, for example, you're working, because organic red meat and organic milk can still be grain finished, right?
I'm not so much finished that there's a limit there under the organic systems. There's
Okay.
or certification. It's got to be 60% forage in the diet at any
But does
one
it say
time.
where that forage is in the diet? So could that
Well,
be
at any one
60%?
time, you've got to
Oh, at
have
any one time.
60%.
Okay.
Yeah.
Not of the animal's lifetime.
No, you can't have them finished solely on grain. They've got to have
So,
60% forage.
so okay, at any one time. That's a really sharp distinction from, and I'm going to ask you to describe the DEFRA definition of grass-fed, which, as I understand, is it was the food labeling say meat can be described as grass-fed if the diet of the animal was predominantly grass throughout its life. Have
I'm
I got that right?
I'm not sure the
Okay.
definition.
Because I believe that was the basis around why Pasture for Life was formed, was because that was a very inadequate way to label things as being grass fed, because it could
Yeah.
be 49%, 51% of the animal's life, and the last part of the animal's life could be finished entirely on grains, and then you've got a product that's no different to conventional, but it's labeled legally as grass fed, which is why Pasture for Life said Pasture for Life should mean pasture for life. But it sounds like unless something's labelled, so organic does mean something with beef. Then that's quite important. Pasture for life absolutely means something. Organic and pasture for life together would presumably mean that the land itself has been treated organically without chemical fertilizer. So you could have pasture for life that still had nitrogen fertilizer put on it.
Yeah.
Organic pasture for life would be even better, but still, when you take away those two, there's such a multitude of finishing that perhaps we should just have nutrition data on beef. What do you think about that?
Um, I agree with you, but I think we need to be very careful about what we do declare to the consumer, um, without following it up, explaining why it's important, or even assuming they've got an understanding of what it would mean.
Okay, but I see a lot of things in supermarkets that say high in omega-3,
Mm.
for example. So that must be a legal term. There must be a legal amount of omega-3 that you can put that on a food. You get it on, like tinned mackerel or things like that, but could
Yes,
that
and
potentially end up on beef?
yes, and the work we did on our the pasture for life beef, that does qualify, not high in omega-3, but as a source of omega-3. There's different thresholds. I should maybe have looked out the levels as to what they are, but the a slight hesitation again, because um, for the long chain omega-3 fats, the legal definition ignores the intermediate one. It just looks like EPA and DHA, which
Right.
are the ones that are high in fish. Salmon and oily fish have almost no DPA, which is the intermediate one, which is actually high in beef. So the European definition of long chain omega-3 doesn't include DPA, but if you add DPA in, our pasture for life beef is a source of omega-3 fats legally.
Legally. Amazing.
But the DPA, and I'm a cynic, and I think, well, because it doesn't appear in fish, and that's what everybody thought of as the main source of long chain omega-3, they just ignored it. Um, and don't count it. And yet the metabolism to go from EPA to DHA, which is the ultimate long chain omega-3 we we need in our diet, the metabolism has to go through DPA.
Right. All right.
That is the
Well,
step en route. So you can't have one without, you know.
but if we go back, like, even say 300 or 400 years, if you lived in, I don't know, what's a landlocked county, Oxfordshire, as a peasant, you weren't eating
Mm,
seafood.
mm,
You were having milk and butter and maybe a bit of lamb and, a bit of pork. So all of your omega-3s would have been coming from land-based animals, right?
yeah,
So it
yeah,
had to.
yeah, yes. It's and they were probably, our ancestors were better, had a better balance of omega-3 in their diet than we have now. That is recognized by the World Health Authority, that organization, that we don't have enough long chain omega-3 in our diet. We
So
need to increase it.
can I and just say no if this is going too far off topic, but I mean I clearly remember growing up in the 80s, this big push to get us to consume margarine rather than butter because they said polyunsaturated fats were good for our heart. Where did all that come from? What was that based on?
Um, I don't know the details, and um, but there's a lot of stuff with the American Heart Foundation that this
Was it Ansel Keys and the
lumped
whole?
all saturated
Right.
fats together, and that was bad. And I'm pleased to say my mother ignored all that when I butter all the way through my
I'm
childhood.
sure you're healthier for it. And well, so can I just ask a bit more about saturated fat? Because people are concerned about saturated fat, and we've all heard the expression "heart attack on a plate," and all those sort of things when referring to things like, I don't know, steak cooked in butter or burgers, or or even cream cakes or whatever, and people describe it as a heart attack on a plate. What what are the saturated fats that are not good for us, and how does that work?
I've got to remember I'm an animal nutritionist and not a
Okay,
human nutritionist. So,
okay.
but in investigating it, there are 12, 14 and 16 carbon chains are the most damaging, and it's all to do with the effect they have on cholesterol levels and the balance between the good and the bad cholesterol. But I don't really want to get into that.
Okay, sure. But isn't 12, isn't that on the top end of medium chain triglycerides?
Yeah, well, 14 I would say is a medium chain, and about half of this palmitic acid, C16, is produced from the volatile fatty acids in the rumen. Half will come pre-formatted, and half will come from synthesized from the volatile fatty acids from the rumen. So that's almost at the edge, between the medium chain ones.
And those end, that sort of end of length, so the 16 palmitic, that's known to raise our blood cholesterol in harmful ways.
Yes, that's right. Although every time you read a paper, sometimes you see things coming up to dispute things, but I'm wary of 16, 14 and 12 are the 16, particularly 14 is which is why we were alarmed when we saw it in the black soldier fly larvae.
But luckily the chicken's filtering it out for us, which is a very good bit of upcycling. So with all this work you're doing, you must be sort of quite surprised about how much, I guess, anti-beef propaganda and rhetoric there is in the world, and you must be desperate to want to throw nuance into that discussion.
Well, yes and no, but I just hope that I suppose the C.L.E.A.R project and Pasture for Life can get their message across, and I'm quite encouraged by certainly over the last couple of years, the sort of regenerative farming approaches that we're seeing going on in farms, and more people are introducing, well, I suppose they've had to get their single farm payment and things, introducing cover crops and things. But I have spoken at a few meetings trying to encourage people to use those cover crops for feeding animals if they've got the infrastructure in place. That would be great, rather than spraying them off with Roundup. So you say getting frustrated by the negative part, but there's also some positive out there that I think I sort of try to focus on the positive rather than everybody knocking beef. Well, not everybody knocking beef.
That's interesting. So a cover crop is, just for clarity, is after your main crop. Let's say you grow wheat and you harvest it in the summer. A cover crop is then an intermediary crop before the next kind of commercial crop. So something you'd put to keep the soil covered, to keep a living root in the soil, but then that needs to be killed off before the next round of commercial crop. And there's two ways of doing it. Then a lot of the conventional way is to spray it with glyphosate, Roundup, which kills it off, leaves the carbon in the soil, but you've essentially kind of nuked the soil biology in many ways. Or you could put animals on it to eat it, and then we're upcycling that into good quality protein and fats to humans. But the problem that I see with that is mostly one of infrastructure. It's not desire or knowledge. It is that an arable farmer doesn't have 200 cows just for a certain time of year. And my thoughts and hopes for the future are that we can have a lot more cooperation within different farming systems to make farms more natural and more complex, where animals and plants are more integrated. And I see a lot of kind of technology helping to enable that. We're able to communicate a lot easier and share information a lot easier. But really, you sort of mentioned the movement towards more regen methods. And hopefully the regen methods are going to be rewarded more by government schemes to encourage more people to do it. And then I guess the nutrient density of everything that we eat improves as a result.
Mm-hmm. Yeah, I mean, you said about the infrastructure, and I think initially I mean, well, there are farms that are integrating livestock, but I think more arable farms could at least start thinking about it, because it will be a major change of mindset for them, because they won't have had livestock on the farm for possibly a whole generation. They'll have no water, they'll have no fencing, the infrastructure does need to go in place. You mentioned,
And knowledge, of course.
yeah. Although I suppose if it's like a share farming approach and the livestock are owned by somebody else
Right.
using the land, then the knowledge will come with them.
So that idea of a sort of nomadic conservation grazing system where livestock farmers would be moving where needed to provide ecosystem services.
Yeah, that would be
Fantastic.
great if it happened.
That's
And
amazing.
maybe no fence technology where they use you said about technology before, they use like a virtual boundary, so the animals, it's a bit like an electric fence, but there's no physical fence, but they can get a shock when they go outside their area.
Oh, is this the wires in the
Animals,
ground? Or is it
no,
done with
it's
GPS
just a
now?
virtual, done with GPS,
Oh,
and
wow.
the animals apparently get used to it very quickly. Whereas they might get a shock once, but then they soon learn that if they go near that boundary, it, and they will avoid it. There's a few pasture for live farms using this no fence technology, it's called,
I mean,
and
it sounds a bit gruesome, but I guess it's just a mild stimulus that's telling them not to walk any further, and then they don't do it again, is it?
I apparently it's not any different to an electric fence,
Right.
which is a temporary fence that arable farmers would put up to contain animals. So,
Yeah, and every certainly every system I've ever seen using holistic management or any form of amp grazing is just using
mm,
single strand electric fence, and
mm,
you and I get a bit of a bump from it, but cows seem slightly less bothered. They're a bit bigger than us.
yeah. They learn to avoid it,
Yeah.
like us who see it as a challenge.
So, is there anything that we can? You mentioned that you see, that just this sort of regen movement coming, but do you see any sort of glimmers of hopes coming from the British retail sector?
Um, in possibly in the financial struggling of society, it might be difficult, because, as we said before, the lower output level we see in their pasture-based systems does make it more expensive.
Right.
It would be encouraging if the retail sector could be a bit more supportive, but
Sorry, the what sector?
the retail
Oh,
sector,
yeah, right, right.
but I'm I'm not sure it's I
So, I mean, it's more expensive because the animals need to live longer on the land, and the land can only hold so many animals. So it's a question of scale. But then the input costs are so much lower that do you think all this organic PFLA beef, the only reason it's so expensive is it a supply and demand curve thing?
um
Or do you think
yes,
there is more?
possibly, and
Yeah.
you're probably in a better position than I am to know about that. I sort of
No, no,
find
fair
the
enough.
reasons why
Something you'll be interested in
better.
is one of the podcasts I did was Fabio Bromovsky, who's chair of the Global Farm Metric, and that is all about collecting farm level data. And interestingly, that was driven by NatWest Bank because they needed to know on their balance sheets for Scope 3, when they were investing in farms and lending money to farms, whether it was fitting their Scope 3 carbon or not. And so they're looking at the ability of the land to generate a profit into the future, and had come to the conclusion that more natural food systems safeguarded the future because of safeguarding the ability to simply produce. And I found it really interesting that from a purely unemotional economic aspect, we're being pushed towards more agroeconomical farming systems. So,
Well, that takes me right back to where I started, trying to get farmers to use more forage because that was cheaper.
Brilliant. I feel like we've just wrapped that full circle.
Yeah.
Thank you, Gillian. Is there anywhere that can you give me some bits and pieces where people can, who have been inspired by what we've been talking about, to read more or follow your work? Or
Yeah, I could send you through some links. And as part of our project recently, we produced sort of consumer-facing notes explaining or summarizing some of the differences. So they don't need to go and look at the academic papers. They can look at something that's easier to digest and explain what we found.
that's very kind. Yeah, if you can send those over to me, I'll make sure that I include them in the notes. And yeah, I'll say I think we've spoken for about an hour, so I think that's a good old block of information. Thank you very, very much for sharing your time.
Okay, thanks for inviting me. Right, bye.
Bye.